Now let's look at PyTorch. PyTorch is an open source deep learning library built by Facebook. One key feature is tensor computing using GPU acceleration. Another is they built deep neural networks using auto differentiation. Tensor is a multi-dimensional data structure or array for programming. We can view scalar as zero-dimensional tensor, and vector as one-dimensional tensor, and matrix as two-dimensional tensor. Here is a cute illustration of the differences between scalar, vector, matrix, and tensor. There are three key modules in PyTorch. The first one is AutoGrad, which does automatic differentiation. So basically, it will record the operations and then replace it backwards to compute the gradients automatically. And the second module is optimization. This implements various optimization algorithms used for building neural networks and other machine learning algorithms. The third module is the NN module, which provides high-level definition of the computational graphs, which is architectures of complex neural networks and other machine learning algorithms. And you can relate this to the machine learning ingredients, which I mentioned earlier. So this is about the structure of the model, and this is about the optimization to obtain the estimation of parameters. And AutoGrad basically facilitates optimization. And another key feature of PyTorch is dynamic computational graph. If you know about TensorFlow, so TensorFlow also uses computational graph, but it's static, so you need to define it first. And PyTorch builds computational graph dynamically, so it is very flexible and easy to program, and is great for research. When we use PyTorch to train a machine learning model, there are basically 4 steps. Firstly, we sample the labeled data using in batches. That is, we just sample a subset of data for training in each batch. And then we will forward it to pass through the network, and then we obtain a prediction. And then we will compute the errors and back propagate the errors so that we can update the network weights. So here, the key challenge is to optimize the objective cost function. And the key over here is to generate that kind of error signal that measures the difference between your current prediction and your target values, typically the labels. And so we use here is some illustration of the optimization where this is like minimization using different, the performance of different algorithms, optimization algorithms. And here is an illustration that we use error signals to change the weights. And the purpose is to get more accurate predictions. And the subtraction, basically we will subtract a fraction of the gradient moving towards the local minimum of the cost function. And this fraction is typically the learning rate. So that's all we want to cover in this lecture. And I need to acknowledge that I have used many materials from many other researchers, which provide a very good explanations of some of the key concepts. And for further readings, I recommend you to check out the logistic regression notes. And also another very good resource is to check out Wikipedia entries on the topics to know at a high level what it means and provide further references. And please check out PyTorch documentations to learn more about the functions, the modules, and of course you need to look at the lab notebook and also the references provided in the lab notebooks. So next, I will also prepare a video to briefly walk through the lab notebooks. And I planned in the end of the week, I will try to put up some feedback to you for this week's material. And I think that's all for the lecture. And next, I will move on to the notebooks.